Okay. So, as a security professional, why do you think it's important to know about steganography?
Malware is hidden in it.
Okay, malware. That's maybe one.
Files, pictures.
What if I'm a rogue employee for your company? Insider threat. So I want to steal data from you. I just stuff it inside some images and start shooting pictures home through my email. You're not going to know. So it's very easy to hide data, This is not really sophisticated. You brought up a good point, though. I mean, for us, just coming through your firewall, you're not going to see it. Or you're coming through your network, you're probably not going to see it. If I get the image and I try to figure out what's in it, or if there's something in it, I won't know. Like, if you still use passwords with steganography. So if I don't know the key, then again, so you can't get the data. So the Discover Me file, this is what the hex looks like. It's not really showing you much, but I mean, this is the hexadecimal representation of it, and there's nothing that's going to lead you to any clues in here that it's been steganography's been used on. I know not everybody got to use the OpenStego because of Java, so I got it here. Extract file, and then the folder is already set up. I set it up. You just click OK, and it extracts it. And then, so that was the main file, Discover Me 02, and then inside that file was a hidden QR code. Could have been anything, though. Could have been text, it could have been a picture, whatever. So they embedded a QR code into it. Anybody have any issues with the other one? The steg detect and embedding text and extracting the text. Fairly simple, easy tools to use. It's a way to communicate with somebody else without them knowing. Covert channel. Okay, so now I'm going to move on. To file carving, file recovery, different things. Basically, if you have a computer, you can recover data off of it. I'll go into more details, but so file recovery, CSI. I mean, if you watch CSI, that type of stuff, when they're on computers doing that type of investigation, they're trying to get files off. They're trying to find out what somebody did. So basically, it's a practice of searching an input. A hard drive, it could be a flash card, a USB drive, it could be a memory card for your camera. Basically, just trying to get your smartphone now has memory cards for files or other kinds of objects based on the content. So if you're doing an actual investigation on somebody, you don't want to take the live data and start messing with it. It becomes evidence. So if you start messing with the live evidence and you corrupt it, then if ever goes to trial or something like that, then you're just going to throw it out saying you corrupted the data. So you always take what's called an image of that data. So if it's a hard drive or a phone, you actually create a secure image of that data, then that's how you work on the data. A lot of the tools out there, the way they locate the files, you use the header and footers of the file. So every file, either your program or your image, is going to have a distinct header or distinct footer. And I'll give you examples of that. So some headers. So PK stands for zip file. The PK comes from the developer of zip. That's his initials. Some common ones also are like your JPEG. So if you're looking for photos, it's going to start off with FFD8 or FFD9. And I think that the footer is FFD9. PDF has a distinct one. So you'll see these in that one screen I had up with all the hexadecimal. You'll see that distinct header. some examples here. So the PNG, which is like an image file, you'll see here it starts off with that character in PNG. So if you're to open up something, you find just a snippet of a file on a hard drive, and you open it up in this type of viewer, and you see that, then you know that's a PNG file. Then over there is an example of a zip file. It has the PK it starts off with. That's the header. So I'm going to focus more on recovering images, and the reason why is because when we went through the competition, that was the thing. They gave us all these bits, all these carvings, I guess, what do you say? Chunks of files that weren't put together. They're all over the place, and then we had to try to put them together. So that's what I'm going to use. It was an actual image, so I'm going to use that as an example. So recognizing the difference, you have digital photos, you have line art, scanned images. So if it's a bitmap, like a JPEG or a bitmap file, it's a collection of dots. It's a bunch of dots, and so it makes up the image. You have vector graphics based on mathematical instructions. The meta file graphics, combination of bitmap and vector. The programs you got out there, you got graphic editors and you got image viewers. So like Photoshop is like a graphic editor. Image viewers, Windows has an embedded one. There's a couple other, like Infinite View, a couple other image editor viewers. So more on the graphic file formats. You have GIF, JPEG, a TIFF, a bitmap. Everybody kind of familiar with those?
Sorry, I'm a little bit lost. You mentioned in competition you got chunks of files.
Yes.
And those chunks of files were from different types, and you had to figure out how to put them back together like a jigsaw puzzle.
Yes.
Multiple jigsaw puzzles.
Yes.
How did you look into the chunks and determine the type of file?
So we use the hex editor, hex view, I believe. We're going to use it in the lab.
Okay.
That's one way of doing it, using the hex editor. And then after that, the biggest part is finding the header and the footer. To get those together, then after that, it's a bunch of trial and error. Very time consuming. Other way to do it, as we talked earlier, is if you're pretty good at scripting, you can actually script it to do it for you.
And so we're looking at this because this is something a forensics analysis would need to do.
Yes. Potentially, so part of the Cyber Patriot, they talked about doing the forensics, and they actually talked about file recovery. So they haven't introduced it yet, but just in case, this is, you'll have a primer to understand what it is and how to do it. And again, there's a very similar here is the Cyber Olympics and the Cyber Patriot. The file names and all that stuff have been very similar. So we're thinking it's very possible they're going to introduce the same stuff from that competition, very similar to that competition. So having experience in that, we can say, here, this is what it's kind of look like. Not going to really go into the vector file formats, but that's what those look like.
And just a note for you guys, the header and the footer, they're very important, right? Because if you don't have those two, your OS will generally not know how to render that file, right? So if you just have the header of a JPEG, it's not going to know what that is because it's looking for the footer to complete the file, right? So you can have nothing in the middle, but as long as you have the header and the footer, you can start working on it. And part of the lab, you'll see that, right? So you'll have a partial picture, but unless you have to have the header and the footer to kind of start off with, right? You can fill in the middle. Those are your kind of your jigsaw pieces, right? And you'll get the snippets and kind of throw them in there. But you have to have the header and the footer, and that's where the file signatures are very important. You need to know what those look like so you can find them.
So I can create a picture, a JPEG, just by using the header and the footer in a normal text editor.
Yeah, so what you'll see if you try to render it, like Windows will understand that at that point. You'll see like maybe the first, couple of rows of the image, and it'll just be like white, and then the header or the footer, right, and the bottom part. So you'll kind of start piecing the image together with bits of that actual picture, and you'll see it in the lab. That's part of the exercise. But just know that you have to have the complete file signature before the OS will recognize it.
These are non-standard file formats. We're not going to mess with these, but there's a bunch of different. There's a bunch of different image formats out there. Google is your friend. I mean, if you need to figure out what they are or the header for the file is, you can just Google them and find them. Digital camera. They have some distinct ways they do the photos when you use your digital camera. So you can use RAW. RAW is where you get a very crisp, clean picture. The problem with RAW, from what I found, it's proprietary, so not all your image viewers can display the content. But you typically see a lot, in a photo from a camera, you get a JPEG and they don't have the EXIF data, so exchangeable image file. So what that does allows inside that JPEG file to have metadata about that image, so where it was taken, or not really where, unless you have GPS on the camera, but when it was taken, the type of camera you used. If you have GPS on your camera, like on your phone, it'll tell you where you're at. So all that data is inside that actual image. And you can pull that data out with some tools like ProDiscover or EXIF Reader. So you can have the image from your camera, and you'll see all the metadata about that. Picasa from Google also does that. A lot of image readers do that now. Anybody think why that's kind of an issue of you're taking pictures and it has all this information about that picture you took?
No, it's fine.
It's fine, especially when someone steals your phone.
So if you post that picture on your Facebook, is that information still in it?
I don't know if Facebook does it.
Yes.
You can pull off the geo. Everybody takes their picture with their smartphones nowadays, right? And generally, I think the default setting is your geotagging is on, right? So it's embedding your geolocation into that picture. You take that and post it to Facebook, right? I can pull that down and strip off that data. Now I know where you took that picture, right? So from a security standpoint, what happens if you're in your house taking pictures and your big screen TV is in the background, right? I now know where that big screen TV is located, right? So that's the danger of the metadata that gets embedded.
So some tools that are out there. WinHex is a hex editor. Foremost will help you do the file carving, actually pull the information together. SmoothKit, Scalpel. If you ever you lose photos on your system, so let me explain that a little bit too. So if you delete a file off your computer, where does it go usually? First place it goes. We'll say Windows, okay?
Trash bin.
Trash bin, okay. So it's still on your computer, right? You empty that trash bin, where does it go?
No, just delete it. I don't know.
Is it gone?
They'll take out the header and
Yeah, I think so.
No, it's not gone.
What?
So all it does really when you delete, it deletes the pointer to that file. So it deletes Windows pointer to find that file, but it's still on your hard drive. It's not actually gone off your hard drive to the point on the hard drive that it's been overwritten. And then even then, some people could probably get it off after that. I mean, there's ways. So NSA or somebody out. So if you accidentally delete a folder with all your pictures, you're like, oh man, I just lost all my pictures. You can actually run a tool like this. They'll scour through your hard drive and try to find those, recover those pictures for you. Or if you screw up on your memory card, same thing. There's tools out there to recover that data. So don't think if you delete something, it's just gone, because it's not gone. So that's why it's like, if you're getting rid of your computer and you have stuff on it, you don't want to really get rid of your computer and it's in your hard drive with it. You want to destroy your hard drive in some other way. It's also good if you're trying to do some recovery is to have different types of image viewers. So not just one, have various types of image viewers to see how they render the image for you. So we're going to do a lab now. So this lab is, we're going to do a file recovery on some files that we get, like the ones that I told you we're getting just pieces of the file, and you're going to start piecing that image again. I want you to see how it works. And then I'm not going to make you go through every iteration of that because it's going to take forever. So once you get through, I think I said 3 or 4 iterations, then I'll have you run the batch script that'll bring the whole thing together. So I'm hand out the lab right now. Any questions on file recovery? You know why? I mean, no issues of why we do it or we have to do it? Or
Why do we do it?
why do you do it? Typically, if there's an investigation, so say you're a network security analyst, and you got to investigate somebody in your office or something like that, or you're a forensic analyst, you may have to go there and see if they're doing something malicious. They may have deleted all their tracks, but they really didn't delete all their tracks, so they don't know what they're doing. So stuff like that, more like doing analysis and investigation.
Now Another common application for this is if, you're doing a investigation on a potential intrusion, right? Someone got infected with some kind of malware or whatever it is. A lot of times a malware will do its first stage infection. It'll pull down some additional file, but it'll try to erase its tracks, and it'll try and delete some of the, some of the files that it used to kind of set itself up. When you're trying to do your investigation and trying to piece together what exactly happened, you're going to need those files, right? So that you can do a full analysis. So that's another common place where we use this technique.